Okay, so what I'm doing here is this, as you can see, is my Miller S62 wire feeder, and that's being powered by my Hobart 450 RVS. I really do intend, a couple of people have asked now, I really do intend to do a whole video on this machine, but what the plan is right now is I have a job coming up next week that I need to squirt a lot of aluminum on. It's just not practical to TIG it, heliarc it. So what I need to do is, it's thick, chunky sections, and it's tight close quarters. So I'd rather not even try to use a spool gun. What I want to do is I just want to squirt it as you normally would MIG. This is just an M25 gun that I run on here. I normally run this feeder. I leave it on here all the time, and I normally run it with I keep a spool of just regular 70S6 wire on here, 035. In fact, I usually use the smaller ones so that they're, the 10 or 11 pounders, so that they're easy to handle. And as you can see, I've already made this adapter here for just that purpose, to keep it spaced out enough so that it goes into the into the drive mechanism squarely. This little spacer here that I made out of aluminum goes on there, and then the spool goes on here, and you can still use your original your original clamp, and it works very well. So now what I'm trying to do is I'm trying to get it, because again, I don't know if this is how successful this is going to be. So I want to just try it with a couple of these 1 pound spools of aluminum. So I made I made up this adapter, and that's why it has the wing nuts on it. In fact, I'll let me put it on here, and I'll explain kind of what I did and what my theory is behind this, and I'll show you and try to explain what I'm doing here. The theory on this is going to be that I needed this, a spindle, in order to mount these spools on, so that it will feed the wire off and into the mechanism, the drive mechanism here. So the theory being that this is something naturally that I want to be temporary, and useful. So that's why I turned this arbor up. And again, I want something I can take on and off fairly easily. So that, I don't know if you can see back here, that would explain the use of the wing nuts. And then I put the knurls on it so that I can grab it with my hand and still, be able to get a fair amount of tightness on this thing, and with the, with the wing nuts to hold it. And then the idea being is that the spool will go on here, but since it's such a small spool, and I just can't have it on there with just a clip or a collar, because there's no way to tension it. This has a built-in tensioning mechanism on here. This obviously does not. So what I wanted to do was make this so that, yes, it's in the right position, and it will feed again into the drive mechanism straight, but I also needed a way to kind of put a small load on it, a drag, if you will, to keep this thing from unspooling and just turning into one huge bird's nest. So again, I'm not sure this is you're seeing this with me. This is as I go here. I made a nylon washer essentially, and then I figured what I would do is again get a way to, so this is just normal, this is a half 13 thread on here, and the steel hardware is just regular half 13 hardware, and then that's where this wing nut comes into play, is this will go on here like this. This is a bitch of one-handed, and I can go like this, and by doing this just a little bit, I can set a load or a drag, I guess you'd call it, on here to set a certain amount of tension so this thing doesn't just, again, just when you drop it on, it doesn't just, and unspool, and I have a big, a big mess of, like knitting yarn here. So that's the idea behind this. Again, so this, like I said, this is an experiment. So then the idea is it will come into the mechanism here, through the rollers, and I purposely, this gun, this is an M25 gun here, just a regular Miller M25 gun, and it's purposely, because I did this some years back with a Miller-Matic I had, and I guess these Miller guns all have same back or whatever. So I bought this gun, it's shorter, I think it's a 10 or a 12 footer, for just doing specifically this purpose. And what I did was I purposely used a heavier wire. I went to an it's 047 or what, 3/64 or whatever, to keep it, hopefully I'll make it a little stiffer. And I do have a pair of U-groove rollers, 045 U-groove rollers that I'm going to put in here. And I did buy I don't even know, they used to be called Teflon liners. I don't know if it's called that anymore. The package just says Miller liner for aluminum. Well, here, let me get it and I'll show you. All right, here's what I was talking about. Here's what the package says. Let's see, can you read that? Just says, Miller, genuine parts, 3/64 liner, 15-foot aluminum wire is what it says. It doesn't specifically say Teflon, but it does look, I don't know, this is never going to pick, well, maybe it will. If you look here, it does look like it's got some sort of a plastic liner. And then on the back it says for an M25 or an M40 gun. Let's see if I can show you that a little bit better. Let's see. Let's see, can we get to the end of this thing? Yeah, there we go. There. Maybe that shows up, I don't know. Yeah, it does look, it's kind of out of focus now, right? Yeah, it does look like there's some sort of a plastic liner in here. So, maybe this side would be better. No. Yeah, it does look, that black part looks like as though it is a plastic liner. And then I have a set of the U-groove, has the U designation on it, the U-groove rollers, 3/64 or 047, and it even comes with the little plastic little plastic in-feed nozzle. And this is the wire I'm going to try to shoot here. This is 4043, 047 or 3/64 wire. I guess these are 1 pound spools, it says. And we'll see if we can make this fly. Like I said, I did have success with this some years back, so we'll see if my little scheme here will actually work. I'll try it. I'll see about getting this liner in the gun. I'll put these rollers on the drive, load a spool of wire in, see if I can set this thing here with a reasonable amount of drag on it, and we'll see what happens. Let me change that out, and I'll get back to you. All right, I've hit a little snag here. Got the liner in the gun, the plastic or the Teflon liner in the gun. I've got the excuse me, the 3/64 or the 047 as whatever they are, U-groove rollers on the drive here. Now the problem is the contact tip. I have an 045 contact tip, but I just tried it on a piece of the wire and it won't go. So what I'm going to do is I'm going to take a contact tip and I'm going to set it in the small lathe, and I'll try to drill it out and see what happens. I guess I'll make it slightly over, actually. I'll make it over 047 or over 3/64 and see what happens there. So let me guess I better take a couple of these with me. I'll take a couple of contact tips and see what kind of luck I can have drilling them. I'll bring you back. Alright, I'm set up here at my little South Bend 9-inch bench lathe here. I have a 3C collet set up in this that I use pretty much all the time. What I've done is I cut a piece of the wire. This is it, the 3/64 wire, and then I took a contact, just a regular contact tip. I purposely took one that's undersized, actually, one of the smaller ones. I took an 030 contact tip and I set it up in the collet and I drilled it, and then I just cut this wire just right off the spool because I don't want to, I want to make sure it's, it's not perfect actually. And I think I drilled, I think it's a 1/16 drill I'm using, but it seems to go pretty well. So I guess I'll do at least a couple of more of these and just see how, see if that'll fly, so to speak. So I'll set this up maybe, if you want to watch me do one, I can try to get a little bit better angle on it. Alright, I hope that'll work. Just like I said, I got a 1/16 drill set up. I got the collet, got the contact tip held in a little 3C collet, and I'm just going to use a little, a little WD-40, I guess, just to drill it through, and we'll see how that works. Let me engage the feed, the drive here, and let's see what we got. Put a little of this. Should be good. And let's see. Not too bad. It's drilling pretty well. Nice chips coming out of there. I don't know. I hope you can see that. Okay. I'll probably have to. Let's see. Let me keep these copper chips clear of this, and make sure I have enough WD-40 on there. I'll probably have to actually move the drill out a little bit in the drill chuck because it's kind of long here, so don't know if I'll be able to get all the way through it. I wasn't able to on the last one. I had to actually just slide the drill out of the chuck a little bit to just give it a little more length to get through. Let's see. I think I got it actually. I think it did go all the way through. Yep, we're good. Since this is on a turret, I can just spin this around. Release that. And we'll take it out. Let's see. I think we have a little air around here somewhere. Blow it out. Alright. Good. Same thing. Let's see here how we do. Yeah, okay, there we go. There's another one. Okay, so that's that. Seems to work out pretty well. It goes, and I don't know, I don't think it being oversized is really going to be that big a deal. I think it's going to be just fine. So as long as it's making contact, we should be all right. So we'll see. I'll know when I try it. That's two of them. I guess I'll just go with that for now and see what's what. I guess I can shut my lathe off here. This is my little South Bend lathe here. It's a 9-inch. I keep this around because a lot of times I do have to do very small pins and things like that. It's absolutely invaluable when you need it. Again, I do have chucks for it and stuff, but I don't know. I don't ever recall ever having a chuck on this lathe. I've always just used it with the 3C collet setup, and I have a pretty good array of 3C collets, and I mostly run it with this turret tailstock on here. What's nice is that when I have to do small threading and stuff, I can use a small geometric head very easily with this, as opposed to just using the regular tailstock and stuff. So yeah, it runs pretty well. It seems to be very accurate, and it's quite handy, especially when you have to do something small like this. So anyway, enough of that little segue there. Let me get back to the deal at hand here, the feeder and the aluminum welding. Let's see what happens. Well, so far so good. I put the spool on the fabricated adapter I made there, tighten everything up, set it for just a little bit of drag with this this wing nut here. And that's on a, like I said, piece of nylon washer, just a regular metal washer, and a commercial lock washer against the wing nut here. So I've set it for a little bit of drag, fed it through. I fed it through the rollers, through the gun, and it seems to be feeding. So I don't know. You can see it. It's not so far. It's not birds nesting up or anything. So I guess we're all right so far. I guess now I'll have to give it some pure argon gas, and I'm sure I have a hose. I'll have to see. I don't know. I'll either bring a bottle to it or I'll get a longer hose or something, and I guess we'll give it a try. Stick around. We'll see what happens. Okay, so I think we were at the point where I had taken a couple of contact tips for my M25 gun, and I had went to the small lathe and drilled them out so that they would work with the 3/64 wire. Okay, I put the U groove rollers in the feeder. I put my spool on here, and I started playing around with my my homemade spindle holder and drag mechanism. I can report that my scheme here worked as far as holding the spool and putting a nice drag on it. There was no unspooling. The rest of it, I'm not. I didn't film it, but I'd be embarrassed to even show it. What's the internet term? Epic fail. Here's some of the, here's some of the results. The bird nesting. Oh, I did. That's right. I left off. I was going to go out and get a bottle of gas off the truck, which I did. I went out and got a bottle of argon, and I connected it through, into the feeder. Yeah, just like I said, epic fail, I think is the word. Just terrible, just terrible. I even took the conduit, for the gun, and I rested it on the, on the handles for the torch cart here, and I'm only working right here. Did I get it to weld? Yes. It welded. I was able to, put crude, beads on there and just try, but the rest of it, unqualified disaster. Absolutely unqualified disaster. So I guess it's going to be on to, I don't know what we call it, Plan B now. So I have another scheme in mind. We'll see what happens with that, and I'll bring you back as I start to get that worked out. This, however, like I said, though apparently it's not going to... Well, I have one other plan. I used this alloy, was 4043. I know years ago when I did this through a Miller-Matic, I used 5356 alloy because I'm pretty sure it's a harder wire. So I'll go to the supply house, the welding supply tomorrow, and I'll get a spool of 5356, in 3/64ths, and I'll try that. But I'm assuming, I'm not hoping for too much better. So, like I said, I'm going to move on to my next plan here, my next scheme, and I'll try to bring it back when I see what's going on with that. Okay, let's see now. It is the next day. I'm not exactly sure. I don't remember exactly where I left this off, but I was quite disillusioned with my scheme here of running the the little 1 pound spools. I had made my nifty adapter here, and I made this little I threaded at both ends. This side I purposely made so I could put a little drag on the spool, and and the scheme was to run it through the S62 feeder. I was using the 4043 alloy, and it was terrible. I was having all kinds of birds nesting problems in here. It was absolutely atrocious. And so here's the gun. So I said I was going to try it again with I was going to pick up a spool of 5356. Well, what a difference the alloy makes. Here, I put the 5356 in. Everything else is the same. and I've got, you know, just a piece of scrap here, and I'm running beads, and it's no hang-ups, no, I mean, it's not great, it's aluminum MIG, how good could it really be? But I mean, shit, this is quite an amazing difference. I mean, it's feeding very well. I've been doing this for, you know, 10 or 15 minutes here now, and you know, I've used up a bit off of this spool, obviously, and now my scheme here seems to be working. Everything here is okay, it looks. Heretofore, I'm not, fingers crossed, I'm not getting any birds nesting or anything here. It seems to be feeding through the gun all right, and like I said, even the welding, I mean, you know, again, it is aluminum MIG, but it's satisfactory. So I'll show you what I mean. I'll set this thing up and I'll draw a couple of beads here, and maybe I'm going to be okay on this. I was in total panic mode yesterday. I said, oh man, you know, this what am I going to do? I broke out my my WC control for my Miller-Matic gun here, and I said, oh, I'm going to have to use the spool gun on this thing, and I hate these damn spool guns and this and that. And I was really, I went home last night all disillusioned, but I don't know. I'm thinking now that maybe I'm going to be okay on this. So, you know, like I said, let me set this up and you can watch me draw a few beads. Well, it's a little spattery, but again, it's aluminum MIG. I mean, shit, I don't know. And this material's only 1/8 inch thick, but I don't know. It's I guess I can fine tune it a little bit. It's working, and like I said, it's the great part is that it's not choking and puking on me here. Everything seems to be running along. I mean, it's not birds nesting up. It's not going crazy here. It's not faltering much. It's pretty decent actually. So I guess with a little fine tuning, I think it'll get the project done. So I guess for now, yeah. Thank goodness for the 5356 alloy there. Let's see, yeah. Yes, 5356. And it's a 3/64 diameter, or I guess that comes out to about 0.47. But yeah, I guess for now I'm going to call that pretty good. So I guess we're going to kind of say it's a relatively successful experiment for now. That'll wrap this up, I think. And yeah, we're going to call it okay. I guess I'll get a couple of more spools of this to have on hand for when I actually do the job, because I gotta get this show on the road with this job. So yeah, I can probably put my my cover back on for my wire rolls here, and yeah, I think, thank goodness, I think we're going to call this okay. We're going to call it relatively successful. I don't want to say it's a screaming success, but I'm going to call it relatively successful. So I guess that's going to be about it for the aluminum, feeding the aluminum through conventional MIG feeder test or experiment or whatever. I'll try to video the job as I do it, and then this will kind of be, you know, you'll see where I was going with this. But yeah, I guess we're going to say it's good. So that's going to wrap this up. Thank goodness. Glad it kind of redeemed a little bit towards the end here. So that's it. As always, thanks for watching. If you're kind of enjoying what you're seeing, appreciate it if you'd subscribe. And always remember, as some famous guy once said, everybody polka. See you next time.